In this video, we will see how to write a C program to check whether a number is prime or not. The question is check whether a number is prime or not. A number is prime if the number has only two factors, 1 and the number itself. For example, 7. 7, it is not divisible by 2, it is not divisible by 3, it is not divisible by 4, it is not divisible by 5, it is not divisible by 6. So we can say that 7 is a prime number. It has got only two factors, 1 and 7 itself. Let us draw the flowchart for this. Start. We can store 7 in the variable num. So read num, or num is set to 7. Then 2 we can store it in the variable I. I is equal to 2. We check whether num mod I equal to 0. It is no here. So go to the next number 3. That means I equal to I plus 1. Again check whether num mod I equal to 0. So this is a loop. We need a termination condition here. So the termination condition is I should be less than or equal to num. I should be less than or equal to num. If it is yes, check whether num mod I equal to 0 and then go to the next number. Once this condition becomes no, we can say that there are no factors for num except 1 and num itself. So we can say that num is a prime. Print prime and then stop. So instead of writing num is equal to 7, we can write read num. So this flowchart will work for all numbers that are prime numbers. Now let us take the case of a non-prime number, 9. 9 divisible by 2, it is no. 9 divisible by 3, it is yes. So we can say that 9 is not prime. We shall include this one also in the flowchart. So we start with 2, I equal to 2. Num mod I equal to 0. The condition false, we go to the next number. I equal to I plus 1. That means I now becomes 3. Now it reaches here num mod I equal to 0. The condition is true. So then we can say that it is not prime and then go to stop. So there are two exits from the loop. So when we come outside of the loop, there should be some condition by which we can check whether we have exited through this way or through this way. So one condition is that if you exit from the normal exit of the loop, the condition becomes false when I becomes num. So we can say that if I equal to num, if the condition is true, we have exited from the loop through this normal exit and we say that it is a prime number and then stop. If it is no, that means we have exited before the normal exit from the loop and we have exited through this path and we can say that it is not prime number and stop. We can write the program hash include stdio.h void main, require the variables in num and I, read num, so printf enter number scanf %d ampersand n, I equal to 2, I less than num, so this is a loop, I equal to 2, then while I less than num, go to the S part, again it is a condition but it is an if else, so if num mod I equal to 0, so we break out from the loop. If it is yes, then break. If it is no, I equal to I plus 1. Since in the else part we are breaking out from the loop. There is no need for writing the else part. You can directly write I equal to I plus 1. This is the end of the loop, so close the loop body. Now go to the now part. Now part there is a condition. If I equal to num, print num as prime, else print num is not prime. So this is the end of the program. You can close the main function. Now another method is that we can set a flag variable. So flag variable is nothing but it is a variable that signals that some condition has occurred. So I take a variable named flag and it is set to 0. Now if this condition becomes true, we change the value of flag to 1 and then exit from the loop. If it is yes, then flag is set to 1 and then exit from the loop. So now outside the loop we can check whether the flag variable is equal to 0. If it is yes, that means we have exited through this way and we can say that it is prime. No means we have exited through this way and we can say it is a not prime number. We can write the program. Hash include std.touch void main in num I and flag, read num, printf enter number, scanf %d ampersand num, I equal to 2, flag equal to 0, while I less than num. If num mod I equal to 0, flag is set to 1 and then break out from the loop. Now in the no part, I equal to I plus 1, close the loop body. Outside the loop body, if flag equal to 0, print number is prime, else print number is not prime and then stop.